As you can see the figure here, there's straight wire AB infinite from one end, and then is another straight wire BC. Then this wire CD, then DE, and it takes a curve and then goes down. So I'm taking this y-axis, this is the x-axis, and this is the z-axis. For all these wires, I have to find the magnetic field at the center O. Before we start, few things I want to tell you that magnetic field for infinite wire is Ki by distance from the point, means this is the wire, and the distance of this wire from the point, perpendicular distance we have to take, and this is taken as A, and then multiply by 2. This is for infinite wire. If the wire is semi-infinite, then you take Ki by A into 1. And if the wire is curved like this, then it is Ki by radius into angle subtended by the curve. Like in this case, the angle subtended is 90 degree. So that is how you use the formula. I will be using the formulas for solving such questions. Also, that if the wire is passing through the point itself, then there will be no magnetic field due to that wire. Now I have broken the points like this wire AB, I am finding for that. So all the wires contribute to the magnetic field at point O. Let's go for AB. So one more thing I want to tell you with direction. Direction, I will be using cross product to get to the direction easily without any confusion. This wire is towards the right side, which is I cap according to diagram given, and the position vector of the point from to where you have to find out the magnetic field is taken from the wire. Okay, so if I talk about this point O, for this AB wire, it is downwards, means minus J. So that is the thing which I will be using to find out the magnetic field. Now let's find out. So B is for AB, BC, CD, DE, EF and FG. That is what I have written. AB, BC, CD, DE, EF and FG. Now let's find for BAB separately. So as I told you, Ki by A into 1 and then cross product I will be using for current into position vector of the point of interest. I cap, and the point is downward, so minus J. So I've written minus J. So I cross J is K and minus is here minus K. So we got the answer. Let's talk for the BC. So BC is passing through the point O, so no magnetic field due to it. Then we'll talk about the CD. BCD. So this was given in the question only. However, you could have calculated. This was given 2A, this was given 2A, and 45 degree was also given in the question. So this was given already in the question, so I was not supposed to calculate. I did not calculate it, it was given in the question. So Ki by A root 2, as I told you, from the wire, perpendicular distance you have to take to the point of interest. Sin 45 by sin 45 is like for a finite wire, wherever the point is. Okay. If this is angle theta 1, this angle theta 2, the point, whatever angle it makes with the end points, and we take these angles from the perpendicular line drawn from the point to the wire. So this theta 1, theta 2 is taken. Here in this case, this is 45, this is 90 given in the question. This is 45 and this is also 45. So the point of interest, from there you take a line up to the end points of the wire. You take the angle from the perpendicular drawn to the wire. That is 45 degree. That is theta 1, theta 2 for you. That is what I have taken. So Ki by distance from the wire, sin theta 1 plus sin theta 2, which is same, and minus Ky. Because this wire, if I talk about the cross product, if we always do current cross with the position vector is taken from the wire like this. So when I take the cross product in this plane, it's a clockwise, and it is clockwise, then it is going inside the plane of paper, which is minus K, and this is given as plus Z. So I've taken minus K. So the answer is Ki by minus K cap. This becomes 1 by root 2 plus 1 by root 2, that is root 2. Root 2 divided by root 2 is 1. So we got this also. Then we go to DE. Again, this wire is going through O if extended. So we will not take magnetic field for it. Then comes the curvy part. See, this curved part is in the XZ plane. XZ plane means this part. So it's like this. Normally we draw the Z axis like this. So I'll draw like that to make it easy. Normally we do like this, isn't it? We are habitual with diagram having Z axis like this. So if I do like this, you can see it's on the plane, it's on the ground. So if it's clockwise, it is going to go inside the plane of paper, which is minus j. So I've taken minus j, and I've taken the formula for the curve also. Ki by radius, which is a, it is given in the question. And since this from x-axis to z-axis, the angle is 90. It doesn't look like 90, but if you look closely, obviously x to z, if you rotate, you will go through 90-degree angle like this. Okay, so 90 I've taken. Now comes this part, that is fg. Again, it's a semi-infinite wire because it's going to infinity from g. For semi-infinite wire, use ki by a into 1, which I've used. Okay, and sorry, this one. And then I am which part is this? Huh. This is minus j. See, it is going down. Down means minus j, and let's go inside because we always take the position vector from the wire. The point of interest is O, and I have to take it from the wire. So from F to O, like this I'm going. So this is minus k. So minus j cross minus k. Minus j cross minus k. Minus minus gets cancelled. So we get ki by j cross k is I. So adding all these, we are getting it. Ki by a I have added, which is this. I am getting a minus k. Then for this also I am getting a minus k. Then minus pi by 2j. Sorry, pi by 2 j, and then I cap. Last one. On adding all these, we get the answer. If one wants to find out the magnitude, he can do this. 1 square plus pi by 2 square plus 2 square. And this will be the magnitude of the question.